today I am going to report chapter 17, which is the satellite communication. What is a satellite? A satellite is a physical object that orbits or rotates about some celestial body. The Earth and the planets are satellites rotating about the Sun, and the Moon is a satellite to the Earth. Satellites are launched and orbited for a variety of purposes. The most common application is communication, in which the satellite is used as a repeater. Chapter 17, Section 1. Satellites orbits. The ability to launch a satellite and keep it in orbit depends upon the following well-known physical and mathematical laws that are referred to collectively as orbital dynamics. Principles of satellite orbits and positioning. If a satellite were launched vertically from the Earth and then released, it would fall back to Earth because of gravity. If a satellite's velocity is too high, the satellite will overcome the Earth's pull and go out into the space. It takes an escape velocity of approximately 25,000 miles per hour to cause a spacecraft to break in the gravitational pull of the Earth. A satellite rotates about the Earth in either a circular or an elliptical path. Circles and ellipses are geometric figures that can be accurately described mathematically. Because the orbit is either circular or elliptical, it is possible to calculate the position of a satellite at any given time. A satellite also rotates in an orbit that forms a plane passing through the center of gravity of the Earth called the geocenter. Satellite height. In a circular orbit, the height is simply the distance of the satellite from the Earth. In geometric calculation, the height is really the distance between the center of the Earth and the satellite. In other words, that distance includes the radius of the Earth, which is generally considered to be about 3,960 miles or 6,373 kilometers. A satellite that is 500 miles above the Earth in circular orbit is 3,960, 5,000 or 8,960 miles from the center of the Earth. Satellite height. Elliptical orbit showing apogee and perigee. Satellite speed. The speed varies according to the distance of the satellite from the Earth. For a circular orbit, the speed is constant, but for an elliptical orbit, the speed varies according to the height. Angle of inclination. Chapter 17, Section 2, Satellite Communication Systems. Communication satellites are not originators of information to be transmitted, although some other types of satellites generate the information to be transmitted. Communication satellites do not. Satellite subsystems. All satellite communication systems consist of two basic parts, the satellite or spacecraft and two or more than stations. The satellite performs the function of a radio repeater or relay station. Subsystems of satellites. There are four subsystems of satellites. First is the communication subsystems, power subsystem, telemetry, command, and control subsystems. And the last is application subsystems. Ground station. The ground station or earth station is the terrestrial base of the system. The ground station communicates with the satellite to carry out the designated mission. Subsystem of ground station. Antenna subsystems. receive subsystems, transmitter subsystems, power subsystems, telemetry and control subsystems, and very small aperture terminal. Satellite applications. There are 3 satellite applications. First is the communication satellites. Second is the digital satellite radio and surveillance satellites. Global navigation satellite systems. Global navigation satellite system refers to the multiple satellite systems used for worldwide navigation. The original global navigation satellite system was the U.S. Global Positioning Systems and still is the most widely used across the globe. These are the types of global navigation satellite systems: space segment, control segment and atomic clocks, GPS receivers, GPS applications.